Hi everyone! Today we're going to continue our investigations on motion. Last week we learned about forces having an equal and opposite reaction, and today we're going to build on that knowledge. Before we do, I want to start off with a little demo. What I want you to do is look very, very carefully and see if you can understand what is happening. What is going on? Let's get started. What I have here is a pendulum, and a pendulum is a weight that is hung from a fixed point. And what I'm going to do is use this bar to push back all of these pendulums so that they have the same start, and then let's watch and see if there is anything that you notice. So some time has gone by, and you saw that I had all the pendulums start at exactly the same time, at exactly the same place. But did the pendulums continue to stay in the same position as the others? Are they going at the same pace as the others? Doesn't look like it. Looks like there's a little bit of a wave. They are not all following the same pattern. I'll let this go for another minute and then we can try it one more time. Okay, we're going to try this one more time. And I have this wooden block here that's going to help me release the pendulums at the same time from exactly the same distance. So again, look and try to see, what does this remind you of? Is there a pattern? Is there a shape? Are they going at the same pace? Are they going to the same distance? Are the starting positions and ending positions the same? Now, when I stop this part, this is a good point for you to pause this video and look at your sheet and write, what do you think is happening? What's going on here? Why are the pendulums all not at the same place at the same time? What pattern does it look like they're following? Why do you think this is happening? So, what did you think? What do you think is happening with the pendulum? Why is it not going why are they not all going at the same speed, at the same time, at the same position? Make sure you filled in your answer. And we're going to answer the question at the very, very end of this class. For now, you're going to need to go to your enrichment bag and take out a few supplies. For this lab, you will need to provide a timer, a pencil, and tape. In your enrichment bag, you have provided for you a tape measure, a washer, 2 pre-cut strings, 2 paper clips. And you will go into your enrichment bag. And inside your enrichment bag, you'll find 2 pieces of string. You will need both of them. So you'll take out one, you'll take out both. You also have a washer and a paper clip. You're also going to need a pencil or a pen. Don't worry about the color or the shape, anything will do. And a table to work on. Here are the steps that you will be following to make your swinger or your pendulum. We will not be using a penny, but you will be using a washer, which is provided for you. That you'll need for the slab: tape, washer, paper clip, pencil, string, a timer, a ruler, or a tape measure. The first thing you're going to do is take your string and take your paper clip, and you are going to pull the string through the paper clip. Not too long, just a little bit, long enough so that you could make a knot. And if there's an adult in the house that could help you, that's fine. So I'm going to knot it once, and I'm going to knot it a second time just to make sure it is secure. Now I took a really short piece. The shorter the better, but it has to be long enough for you to be able to handle it. Now you'll see what I have is my string connected to the paper clip. Now I need to measure a length of 38 centimeters. We are working in centimeters, not inches. And that's from the top of my paper clip. So I'm going to line it up with the 0 mark. And I am going to measure. I'm going to find out where 38 centimeters is. Right there is the 38, and I'm going to just pinch the 38 where the 38 would be, and I'm going to hold it. With my other hand, I'm going to squeeze the 2 pieces of string together, creating a loop. And now you will need a piece of tape, really small piece is best. Might make sense to actually pre-cut your tape in advance. So I have a small piece of tape. I'm going to just loop it around. And now I have made a pendulum or a swinger. The only thing missing right now is the weight, and that's where the washer comes in. So what I'm going to do is take my string, move it to the top, and now the paper clip, this little part, I'm going to fold out just a little, and then I'm going to bring my washer and just hook it onto the paper clip like this, and here is my pendulum. The next thing you need to do is take your pencil and some tape, and you want to have the pencil stick out from the table, and you're just going to tape it to hold it in place and make sure it's nice and secure. I like to add a second piece, a little bit lower, and even a third piece to to make sure it is absolutely secure. Now that we have our pendulum assembled, you're going to take the top of the loop and you're going to place it onto the pencil like so. Now you will need a timer to help you time. Now that we have our pendulum onto our pencil, you need to get your timer ready, and we're going to see how many swings does this pendulum swing in 15 seconds. Now I have to just explain the definition of a swing. When we start the pendulum, it's going to start off parallel with the table, not higher, not lower, and we're going to hold it nice and taut. We're not going to hold it loose like this. And once I let go, I'm not going to touch it again. It's going to swing back and forth. And each time it swings and comes back and crosses the midpoint, that's how we count one swing. So let's see, let's go through a practice. 1, 2, 3, 4. You notice that it's not coming all the way back to the starting point, but as long as it crosses this midpoint. Now I'm going to set my timer for 15 seconds, and we're going to count the number of swings this pendulum that is 38 centimeters long makes. I have set my timer to 15 seconds. I'm going to hold my pendulum and I'm going to press start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to stop. So for my first attempt, my pendulum swung 11 times in 15 seconds. We're going to try this 2 more times just to be accurate. Have my timer set for 15 seconds. Going to hold the pendulum, again, parallel to the table, nice and taut. I'm going to press start and let go at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got 11 swings twice. We're gonna do this one last time. Have my timer at 15 seconds. Pendulum's ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to stop. Now that we have completed the first part of the experiment, we need to take out our data sheet and record our observations. Now, while you're doing this, I recommend you record your observations as you're doing the pendulum swings and not wait till the end, because your numbers may be different. So we did 1, 2, 3 trials and the number of swings. My number of swings for the first trial was 11. My number of swings for my second trial was also 11. And number of swings for trial 3 was also 11. Now, you may have a bigger number, you may have a smaller number, you may have different numbers. As long as you're in the range, that's fine. Now, if you get 20 swings or 22 swings, you've done something wrong. What have you done wrong? You counted your swings wrong. If you have one at 22 and the other at 11, well, you count the 11 because that was the one that occurred most. For pendulum 1, the string length was 38 centimeters, so we're going to record that. Now you need to make a hypothesis. Two different hypotheses actually. If the string length increases, so remember we had a string length of 38 centimeters. What happens if we increase the length to 50 or 60 centimeters or even higher, 70 centimeters? Do you think the number of swings will increase or decrease? Go ahead and fill that in. If the string length decreases, so if we take our string length and go smaller than 38 centimeters, if we have a string length of 20 or 15 or 10 centimeters, then the number of swings will it increase or decrease? It's a good time to pause, fill out your hypothesis. Now for the second part, we are going to change the length of the string. This is going to be the variable that we are changing. This variable is called the independent variable, the one thing that we change in an experiment to see how it affects the experiment. You can either decrease the length or you can increase the length. I will give you 4 choices of string length. The 4 different choices are 15 centimeters or 25 centimeters. That would be string lengths that are shorter. Or you can increase the length by choosing a length of 45 centimeters or 55 centimeters. Go ahead and choose the length and fill that number in here. Once you have chosen the length, you're going to use your second piece of string and you can build a second pendulum like we did the first one. I'll walk you through the steps one more time. If you prefer, you can also use the same pendulum you had before by simply removing the tape, pulling them apart, and slide the tape right off. You'll take the washer off just briefly so that you can measure. So feel free to use the same swinger or build a second one. I'll go through the steps one more time. So again, you need to start with a paper clip and your string. You're going to pull the string through the paper clip and make a knot. That's 1. And 2 knots to make it secure. Bring out your tape measure. I'm going to make a swinger length of 15 centimeters for now. So I'm going to bring the string all the way to 15, hold my finger there, remove, pinch together, creating a loop, get a piece of tape ready, and there you have it. Now if you have extra length, you're going to fold it over and you can tape that so that it's not in the way. It's not really necessary to do this step, but if you want to just ensure that it's not in the way. And now you have a pendulum. The only thing missing is our weight, right? Our washer. So now we are going to test a swinger of length 15 centimeters, but we're not going to change the time. We're not going to change the weight. We're not going to change the type of string. The only thing we're changing is the length of my string. At this point, you should be paused You should have your own experiment running before you see my results. Let's try a swinger that is 15 centimeters in length, and we are going to try the same amount of time, which was coincidentally also 15 seconds. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I got 17 swings. Let's try this one more time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I got 18 swings. You'll notice some of the swings are irregular. There was a little bit of interference. I could count it, but if you see that yours are completely off, do more. Do 4, do 5, do 6 trials. Let's do this one last time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to record our data as if we were in class. I'm going to try all of the lengths so that you also have a record of what the results would be. At 15 centimeters, we got 18 swings 2 times, so I went with that number. We had 18 swings. Now I'm going to try 25 centimeters. Here is my pendulum of 25 centimeters, longer than 15 centimeters. Again, I'm going to set my timer to 15 seconds. Hold my pendulum parallel, taut to the table. And again, as soon as I start my timer, I'm going to let go. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're going to try that 2 more times. I'm going to start it and let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We had 13 twice at 25 centimeters. Let's try it one last time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now if we look at our next result, at 25 centimeters, we had 13 swings. Now we have to increase it to 45 centimeters. Let's try our pendulum with 15 seconds at 45 centimeter length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 twice and 1 last time. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 3 times for pendulum. I went ahead and I added the 45 centimeter string length and the 38 because that's part of our results as well. And as we look, do we see a pattern starting to show up? As the string length increases, what's happening to the number of swings? Let's try one more. Let's try our last one, 55 centimeters. This one may be a little bit tricky to do. You can still do it with the string length, but the string is not very long. So you have to make sure to tie it exactly the right place. Now we have our final pendulum that is 45 centimeters long, and we're going to test to see how many swings will it swing in 15 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have our final result. At 55 centimeters, we had 9 swings. This pattern looks like it is decreasing the number of swings as the string length increases. Or we could say that as the string length decreases, the number of swings increases. Now, go ahead and fill out your pendulum sheet and make sure to write in your conclusion. Now, the way we write the conclusion is, as the string length increased, what happened to the number of swings? Or in your case, if you changed the string length and you decreased it, as you decrease the string length, the number of swings increased or decreased? Well, we know that as the string length increases, the number of swings decreases, and as the string length decreases, the number of swings increases. Now, let's come back and visit our first pendulum. Now I have the pendulum again, and just because I love to watch this, I'm going to do it one last time. What do you notice? The same thing, right? Are they all going at the same rate, at the same place, at the same time? They're not. Now can you answer the question? Now do you know why this is happening? The string lengths are all different lengths. It's hard to tell because they're really close. They're just slightly different. Ours were really big differences. We jumped about 10 centimeters each time. But these almost look like they're the same exact size, but they're just a slight difference. A little bit taller each time. But as the string length increases, then the number of swings decreases, so it takes a longer time for it to swing. The shorter lengths have a shorter time and shorter length so they can swing faster, it seems. Now we can relate this, I'm gonna have them stop. We can relate this to our planets. Think about the planets that are closest to the sun and the planets that are furthest from the sun. Which ones take a shorter time to orbit and which ones take a longer time to orbit? Well, Earth takes 365 days to orbit. What about Neptune, the furthest planet? Does that take more days or less days? Just to share some fun facts with you, Mercury, which is a lot closer to the sun than Earth, takes 88 days to orbit the sun. We know that Earth is 365 days. Now Jupiter is further than Earth from the sun, and that takes 12 years to orbit. Now Neptune, again, as I said, is the furthest planet, and that takes 165 years to orbit around the sun. Now go ahead and try different lengths. And remember, we only varied the length today, and we call that the independent variable. The independent variable, the string length, changed the dependent variable, which was the number of swings. Can you think of other independent variables that we could have tried? Think about it.